Hello, everyone. Thank you for joining my session today. My name is Rawan Adawi. I will be discussing teaching computational thinking skills through coding and ICT support. I would like to also thank Wonder Workshop for allowing me to present in their international summit. So, first, I'm going to introduce myself. I currently reside in Lebanon. I have 9 years of teaching experience, half math and half ICT. I have a bachelor in elementary education and a master's degree in educational management. I've been working on technology consultancy and tech coaching in my current school and as a freelance. I have different badges from Microsoft and other organizations. I have my own YouTube channel, and you can contact me on my personal email accounts. So in our presentation today, we're going to talk about background information about computational thinking, and you're going to see the connection between computational thinking and international standards, how we put computational thinking into action, and the troubleshooting and connection between troubleshooting and computational thinking skills. Let's dive deeper. So first, I would like to ask you, have you ever played the game The Sims? It's a really nice game. It's one of my favorites. It actually allows you to create your own environment, your own characters, and different settings. You can always choose different traits for your characters and so on. So within this game, we actually work on the skills. It's a skill based game where you set up your characters and then you try to train them so that they improve and then they become more skilled and then they kind of upgrade their own skills. So it's technically the same way we deal with education and the same way we deal with our students. We want to enhance their skills. Not all of them have the same pace, not all of them have the same skill as well. Each one of us is unique, but we can always work on our skills to improve. This is the cool part of it, and that's how it connects to my favorite game, which is The Sims. So, some background information about computational thinking. If you're thinking about it, there are four components of computational thinking. You have decomposition, which is kind of how you break down a problem into smaller parts to solve it later on. And then you have pattern recognition, which is how you identify similarities, differences, some trends that are happening. And then with abstraction, you kind of isolate or ignore the irrelevant information that might not be helpful for you to solve the problem, and then you focus on the important ones. And then you got algorithm. So with algorithm design is the way you're developing your step-by-step instructions in order to solve your problem. So sometimes you hear about generalization. We're going to talk about it later on. So um, Janet Wing is one of the pioneers for computational thinking. She pushed for computational thinking to be taught outside a computer science class. As for her, it has to be taught through reading, writing, arithmetic, and so on. And it's a very important set of skills for every child's analytical ability. Some are also mentioned that computational thinking is applicable everywhere around us in our daily lives. And others mentioned that computational thinking should be taught as the fifth C. So, if we're talking about collaboration, communication, critical thinking, and creativity, computational thinking could be the fifth C that we need to teach our children for the 21st century. Now let's look at computational thinking and the connection with metacognition, or let's say the cognitive domain. So this is one of the models that Cynthia Sylvie developed so that she categorizes or tries to draw a connection between computational thinking aspects and how they categorize or where are they in the Bloom's taxonomy. We're talking about the cognitive domain over here. So if you notice, you would find decomposition, abstraction, and algorithm at the highest levels of Bloom's taxonomy. Take a look at it. All right. And now, in a nutshell, computational thinking is definitely a higher order of thinking. It has different components. We mentioned many of them before. Generalization is visible in this model, which is how you develop your own insight and the rules that you will apply in other contexts. You can take a look at this model. There's also the link at the bottom of the slide in case you wanted to know more information about it. Now, let's talk about the connection with international standards. So computational thinking was really highlighted in a really big importance, and it has its own page on the International Society Technology of Education, the website of ISTE. So you could find a big page for computational thinking, and they encourage educators to learn how to use computational thinking. This is the PDF of those standards and how we need to acquire those competencies in order to teach them for our students. So also with ICT standards, you could find also a course specific just for computational thinking. I really encourage you to take a look at it and to try to take this course. It is really helpful. It shows you how it's applicable in music, arts, and in many fields, not just in computer science. Here's another connection with other international standards, like the K-12 computer science framework, and there's the CSTA as well. So you would find computational thinking in their standards very visible. And then we're going to move on to how computational thinking was implemented during my coding lessons. So I tried to show you computational thinking in many of the practices that we had on code.org, one of my favorite websites to use with the students, so that I teach them coding practice and technically indirectly teaching them computational thinking.
Hello! In this level, Laurel needs to collect the diamonds. And every time she wants to collect one, it's the same pattern if you notice. So we have a repeat 3 indeed. I'm going to put it aside and then I'm going to program the first one only so that I know what is my pattern.
So in this practice, the first thing that a student would do is to stack the blocks on top of each other. So you would see that we have east, east, get, then east. This is the pattern and the code that was built by a student. So this is kind of building an algorithm. If we move on, we want to recognize the patterns in this model. So a student might stack the blocks like that, and then I ask the students to read them loudly. When a student starts reading them loudly, he would recognize the pattern by hearing it. So when you say east, east, get, and then east, east, get, east, east, get. So it's kind of identifying that there are some sort of blocks that are repeated. And then from here, we go to decomposition, and then we try to decompose the code and to place them next to each other so that we see how we have a pattern that is repeated, and we want to use a different way or an easier way to solve this code. So what happens is that over here we introduce something called the loop block, which is the pink block right here. It's the repeat block. So abstraction is realizing that a loop block would be very helpful here to reduce the number of blocks that were used. And this is how we started using repeat blocks. Now, in a nutshell, using those skills, uh, solving those problems, the way we approach those problems and the way we teach the students how to think about solving them is really helpful for the students in their future situations in their real life, not just in computer science, not just in coding. So I want to also tell you about the debugging lessons that you can find on code.org. or probably on other platforms. It's a really important concept and skill that we want to teach our children about. It's how to identify the errors, the mistakes that are in a code and to fix it. So over here, if you notice, we are using a lot of analytical thinking skills. On code.org, they have their own videos to explain those. And then they have their pre-prepared lessons and then the practices that you see over here. So in this practice, it shows you the existing code, and then you need to try it out and to figure out what is missing in this code. And we use that not only in ICT or in coding. You could have similar situations in sciences, in math, in different areas. It's how to identify what is missing as an element in your problem in order to solve it. Over here, you have the debugging also, but this time with fixing the code. So this time they give you a code that is not really correct and that you need to fix it. In this code, for example, he has to move one step forward and then to turn, whereas over here we have three move forwards. This shows them how you can fix the code by removing or isolating some of the unnecessary blocks. And this is technically abstraction. This is how you're solving it. You're decomposing the code, you're isolating the unnecessary blocks, and then you're fixing your algorithm design again in order to solve your problem. So you're using all of those skills in computational thinking.
This lesson is called Happy Maps. Today we're going to help our furry little friend, the flurb, get to her fruit.
Make your flurb go to your fruit.
To do this, you'll need to figure out which way the flurb needs to go and direct her with arrows.
In order for the flurb to get to the apple, what direction does the flurb have to go?
Mine, make it go up. And to get it there, you circle the direction that it has to go.
Create your algorithm by gluing arrows next to the map that you're trying to solve.
In the second one, it's the same, but it's going down.
It's like programming with paper.
And that's it.
Over here, you would see also some worksheets that we use as unplugged lessons. What I did is that I printed out those worksheets. They are ready-made by code.org, and I laminated them and used them in different centers. There are also videos to explain how to use them in this activity. So you would notice that the students are using them within their centers. We can erase and reuse them again with different areas. So unplugged is very important because it starts by showing the students how those problems could be tangible for them, how they can try them, how they can imagine themselves, the character and going to get something. And then they play it around before that they start practicing it on the iPad or the laptop. There are also unplugged lessons that are for higher grade levels. So you would notice that there's one with the robotic friends, there are videos, a complete lesson plan with the objectives, and so on. So I'm going to show you right now examples of using city skills in coding. So let's take a look at it. Over here, this is one of my favorite, and I'm really proud to share this with you. It's one of the students in KG2 who was actually able to build his understanding about how to use loop blocks within one practice. And all of his work is really visible and it shows all the steps in computational thinking. So he actually stacked the blocks on top of each other first. And then what he did is that he recognized, okay, so there's a pattern over here that is repeating. So he kind of used algorithm design and then pattern recognition. Then he decomposed this pattern and used a loop block with abstraction. And this is how he was able to build his code. This is really, this is amazing. Another one is over here. This is for the same student. It's another practice. So after solving the first one, he was able to directly build an algorithm he used generalization in this one because he used loop blocks directly. And he built an algorithm with the repeat blocks this time to solve the problem. So can you imagine a KG2 student using those skills? What about other grade levels? So a student in grade 3, for example, so this student was with me since grade 1. And we kind of worked step by step, so it's kind of constructivism. We taught the students about different skills in coding, and now in grade 3 we are able to introduce conditionals, nested loops, if else blocks. So those uh, terms in coding are kind of challenging, but when you approach them with code blocks, and when your students have the mentality already there and you train them well, then they would be able to make it easily. So you would see that this student solved different practices using nested loops, using different sorts of blocks like conditionals or even the if block over here. I put the link for you to access every practice if you want, so you can click on them in my presentation slides. Now, this is another practice. This is not code.org anymore. It's on Codeable. So this is one of the practices that I used during the hour of code, and we extended this practice to our regular coding practice with grade 1. Our students were able to discover the loop block and the functions throughout this game. And you can find out that here we built an algorithm design, and over here there's the repeat block and then the functions. In grade 2, we have students who built their own projects using different skills as well. This is on Scratch Junior, if you heard about it. It's a really nice and creative application for the students. It's really engaging. And they created their own conversations in this practice. So you would notice that the student used some sort of color code so that to use different event blocks with different color codes to create the conversation, to send messages to each other in the conversation. And then you see the algorithm design over here. There's also the repeat block. So this practice came after working on code.org. So it was kind of a transfer of skills between the different platforms. The same applies to Codeable from before. And over here, I want to talk about discernment. What I want to say is that when you're teaching coding, sometimes it depends. Are you teaching coding as a homeroom teacher, or are you teaching coding as an ICT teacher and that you are responsible for other technology skills as well? So this is exactly my case. I'm an ICT teacher. I teach part of my curriculum is coding, but there is a big part as well about communication skills, video making, keyboarding, and design. So over here, it is very important to know what will you be choosing to focus on. So I'm focusing on the concept more than the quantity. The quality is more important than the quantity over here. And of course, I cannot finish all the courses in code.org. So over here are the courses. So I cannot finish all the courses with my students, but I know what to choose, which lessons I want my students to learn in course A, which lessons I want them to learn in course B, and so on. Now, in KHG2, we use course A, grade 1, course B, and upwards the rest. So, but of course, in course A, most of my students would finish most of the course. In course B, we skip lessons and we move from a lesson to the other, but we make sure that we acquire the knowledge about using loop blocks, for example, or using different event blocks, for example. And then in course C, we'll also skip some lessons, but we make sure that we introduce conditionals, if block, and so on. Now, some of the reflections from my students. So those reflections are really, they're really touching for me. I really love them. About KG2 student, it was really touching to see that a child wasn't able to know the left and the right. And now after coding, he is able to know north, south, east, and west. So this is really touching. In grade 4 as well, one of the students mentioned that it helps him improve in his way of thinking with the brain. He wasn't able to put it in the right way. And then over here, it just makes him happy. So, how to support your students in a virtual learning when you're teaching coding language or teaching those computational thinking skills? Um, as an educator, I developed my own ICT channel, a YouTube channel, and I have my own ICT website. So I created a bank of resources for the students, a bank of videos on my website so that they access the tutorials and they learn more. I also want to say that scaffolding is very important because you can put students together who are at the same level so that they learn from each other. And this is exactly what I do virtually. I use breakout rooms, and those who are in level 6, for example, will sit together. Level 9 will sit together. And so this is how we differentiate. And at the same time, we make sure that the students are elevating or moving on to the next levels, learning from each other. So that's really important. This is the end of our first part of the session, which was about how to use computational thinking in coding practice. I hope it was helpful. Now let's dive deeper into troubleshooting using city skills. Well, that was really funny. I hope you enjoyed this video. I showed you this video because in troubleshooting, clients, I mean, students, educators, or even parents, they might come to you with some frustration, different feelings, mixed feelings. So you need to know how to solve the problem with them and to calm them down. And this is really an important skill that you need to learn. And computational thinking can actually help you and help the parents thinking about the solution and not to focus on the problem itself, focusing on the solution more. So, moving on. So, the way we give IT support requires us to think more, to use a lot of thinking skills and a lot of problem solving. It's at the core of it. So, in troubleshooting, computational thinking can become very handy in this area. So over here, I'm suggesting that you build a culture of problem solvers in your workplace. And this is exactly what I tried to do. So when we suddenly went into a virtual setting, everybody started directly using technology and we're learning about technology and through it and so on. Now, when everybody is using technology, you won't have enough HR individuals or probably IT, by this I mean IT people who are able to support. So you need to help the community to learn how to troubleshoot. So everybody is concerned over here. Everybody is responsible about learning the technology and how to troubleshoot. This is why using computational thinking skills can help you solve the problems for everybody and can boost the tech support in your organization. And you can teach that. You can use every troubleshooting area or every troubleshooting scenario as a teachable moment so that the next time a person comes to you, they would have tried different things before they come. So the way I supported my colleagues at work was to use different ways. I created my own ways to communicate and to help support the community. So for the parents, for example, on the school's internal website, I created a tech support page and I always updated with videos and examples of how to solve things. On private chats and Teams, I created private groups with the grade level members so that I contact them directly and troubleshoot with them. There's also my YouTube channel, which was really active recently. I've been uploading videos to support teachers, students, and even parents. So over here, I'm going to show you some of the scenarios from my personal experience using computational thinking while troubleshooting. So this is the first scenario, and this reminds me of my first experience delivering a workshop in my current school. So what happened is that we wanted to connect multiple devices to a router in the library. What happened, I was using 20 devices, almost 20, and we couldn't connect. Not even my laptop was able to connect. So I started panicking, and I did not have enough experience back then. It was kind of in 2019. I did not have the experience that in troubleshooting. So I started panicking, and I got frustrated. And then one of my colleagues, and I really would like to thank her, it was Sally Yahtet. She is my mentor. She approached me and started kind of guiding me with the questions so that I'd be able to solve the issue. So with her question, I was able to think, and the skills that I used to think were actually related to computational thinking. Her questions were like, okay, what is the problem? Identify your problem, and then I was able to identify that the router probably the devices are not able to connect with it. And then, okay, she asked me what could be the reason behind this, and then I thought, okay, so the router could be overloaded. Maybe we need, so what could be a possible solution is to decrease the number of devices. And this is exactly what we did. We started first decreasing the number of devices, 3 per table, and then we used kind of abstraction over here that 3 did not work with us, so we had to decrease the number to 2 and then to 1 device per table. So solving this problem, the way we thought about it, the way we brainstormed, is actually related to analytical thinking, to critical thinking skills. So this is one of the scenarios. Another scenario is when a student comes to you and not able to share the screen. I had like, I don't know, I cannot count them anymore. I had many cases the same way, how to share the screen, and it's not able to do that. So with this scenario, you cannot just go on autopilot and say, okay, restart your computer. That couldn't be the issue sometimes, or most of the times. Or you can say, for example, uninstall and reinstall Teams. That wouldn't help. So what you want to do is to start first by asking questions, gathering data. This is what you need to do. And with the questions, you would be able to identify which area is not working and how to fix it. So if you're asking, for example, how you're accessing Microsoft Teams, the student would tell you one of those options. And then if it was a desktop application, then the solution would be A, for example, which is accessibility. So with guided questions, you would be able to decompose the problem, and then you would be able to figure out a solution by using, for example, abstraction, isolating things that are not necessary or that are not affecting the problem, and then figuring out where is the solution. Now, I would like to suggest that if you are an IT support, or you're working as a help desk, or you want to even enhance your skills in tech support, I encourage you to take the Google certificate, the Google course for IT support professional certificate. It's a really nice course. I took it with Coursera. It has different scenarios. It teaches you how to think, how to solve problems, and it's really, really recommended. They also have the computational thinking skills indirectly taught within this course as well. Some of the takeaways from this course were the pitfalls in troubleshooting, how to avoid those pitfalls. So, to not fall into autopilot is really important. So, not every problem can be solved with the same way. Every problem has its own case and could be solved in a different way. So, always ask questions and gather data. And sometimes There are many, many small problems around the big problem, so do not get distracted. Try to find a root cause for the problem, and probably one big problem could be causing different problems around it. So finding the root cause would help you in this case. And always test different ways before you take major decisions about uninstalling, restarting, rebooting. I don't know. Uh, Big decisions, you need to take them when you tried every possible solution. So, first, always test your solutions, test ways before you take a big decision.
Tech support, how can I help you?
Hi, I'm having trouble with my computer. It doesn't want to print.
And you've tried the usual troubleshooting?
Yep, I'm usually pretty good with computers.
Tried turning it off and then on again?
Yep, tried that.
Any flashing lights on the printer?
No flashing lights.
Okay, I'm just going to log a job for you. Damn, sorry. I seem to be having an issue with my computer at the moment. Do you mind if I put you on hold?
No, that's fine. Tech support, how can I help you?
Hi, I'm having troubles with my computer at the moment and I can't seem to log a job.
Have you tried turning it off and then on again?
Yeah, already tried that. I'm usually pretty good with computers.
Any flashing lights?
No lights.
Do you mind if I just put you on hold for a second? I'll need to speak with a senior technician.
Yep, not a problem. Tech support, how can I help you?
Hi, I'm having trouble with a client who can't log a job on his computer.
Yeah, that's a common problem. I've come across that myself. Have you asked them to try turning it off and then on again?
Yep, I tried that.
Asked about the flashing lights?
Yeah, I asked about the flashing lights.
Jiggling the cable?
No, this wasn't a cable jiggling issue.
Do you mind conferencing me into the call?
Not a problem.
You've got the senior tech on the line. What do you need to know? I think we've got a cross line. Anyway, it seems we're having computer troubles. And you've tried the usual troubleshooting?
I'm usually pretty good with computers. I just need to change over the printer queue.
Well, I can just reset that on this end.
That should solve all your problems.
All sorted. Glad to be of service.
All fixed. Thanks for calling.
You're pretty good to go. Was there anything else?
No thanks. Have a nice day. Is that printout you asked for?
And then I'm going to share some tips for troubleshooting. Always make sure to greet your audience, your clients, with a positive attitude, and this will lead to a positive interaction. Stay calm and acknowledge the feelings of others and show them that you're ready to help. Being transparent is very important because when you are transparent, it means you know what you're doing, and this way the person will calm down and would know that you are honest and you really know that this is the problem and how to solve it. So being transparent, sometimes you might say terms that are related to IT or stuff that is not really familiar for the client, but it's okay as long as you are transparent and telling them that this is the problem and we have to fix it that way. And the last minute really shows the last impression for the parent, student, or teacher. So try to end your interaction positively as well. If you want to connect with me, I have a LinkedIn account, Twitter, or YouTube. And thank you for your time.